Now 2.1.3, calculate the volume of the lead used. Remember, the lead is the hemisphere. Now if you want to know how much of the lead was used, we are going to take the volume of the hemisphere and subtract the volume of the cone. So this whole thing is lead. This one inside is aluminium. I hope I'm explaining it clearly, but the main thing is the volume of the hemisphere minus the volume of the cone. That will give me 41,003,979 minus 15,707,963, and that gives you an answer of 2516,106 centimeter cubed. Awesome. Now 2.1.4 says, for the parts to stick together, a special glue is spread on the curved surface of the cone. So on the curved surface of the cone, so the outside of part of the outside of the cone is glue is put on it. All right. Now calculate the slant area of the cone. Let's look at the slant area of the cone. Let's go and look at the formula for the slant area of the cone. Slant surface area of the cone. Here is the slant surface area of the cone. It's pi r L or pi r slant height. So for us to calculate the volume of the cone, we are going to first have to calculate the slant height. Just underneath is the formula for the slant height. So what's the formula for the slant height? That is slant height L or S or HS equals to perpendicular height plus r squared, square root of perpendicular height plus r squared. All right, then that would be perpendicular height of the cone is 25 squared, r squared is 24, r is 24 squared. All right, let's leave it there for now. Then the formula for the surface, the curved surface area of cone is pi r and the slant height. So our r is the 25 centimeters, and our slant height, I can just write it like this. If I want, I could have gotten the number first and put the number in. It's up to you, completely up to you. Then that will give you an answer of 2,721,832. I hope that one is clear. Then its surface area is centimeter squared. All right. The next one now is 2.1.5. Calculate the total surface area that is painted. Remember, it said the metallic hemisphere is coated with gold paint. So now the entire hemisphere is coated with gold paint, calculate the surface area. So we're just looking for the surface area of a hemisphere. So to do that, we are going to look first. I want to explain it clearly. Let me do it like this. Choose a different color pen. So this is what's painted. This whole thing is painted, even the top. The sphere, the half sphere is painted. And now what? This circle on top. Remember, a normal sphere would not have this circle on top. It would be a ball all around. But now it's no longer a ball. It's half a ball and the top part. So we have here, this will be half the surface area of a sphere. Then this also here is painted, and you can see that's a circle. So this will be the area of a circle. So what's painted gold? Half the sphere and the circle. So we are going to have here we are going to add half the area of the sphere. Remember, then this is the area of the hemisphere, plus the area of the circle on top, area of circle. The area of a sphere, let's go and look at it. The area of a sphere is 4 pi r squared. So this is 4 pi, what am I saying? Excuse me. 4 pi r squared plus the area of a circle must be here somewhere. I don't seem to see it, but anyway, it's pi r squared. From level 2, it's pi r squared. So I'm going to have half 4 pi. Then we have r squared is 25 squared plus pi. Again, the area of the circle is still 25. I hope I'm making sense. All right. One may ask, why is the volume not included? Because the volume does not form part of the outside. Excuse me. One would ask, why is the cone not included? That's because the cone does not form part of the outside. The outside is just the hemisphere and the circle on top. All right, when we calculate that, we get a value of 6,870,663 centimeter squared. All right, that is done. Awesome stuff. Now we are going to go straight forward. We are going to look at 2.2. So now I will be going up for my formula sheet, no problem. Let's bring it closer here. All right. Now, I hope it's still visible. Let's go. 2.2.1 says determine the equation of line AB. Oh, we're just in the form y equals to mx plus c. So it's literally the equation of a straight line given 2 points. I have my 2 points as they are. How do we do that? Number one, we find the gradient. Let's find the gradient. What am I saying? M equals to y of a. We are looking for the gradient of AB. So y of a minus y of b, and x of a minus x of b. Then ya is 8 minus yb is 4. Yb is minus 6. Yb is minus 6 over xa is 4 minus xb is minus 6. Still, I am going to have 14 over 10. Simplified gives you 7 over 5. So we have our gradient. What do we do now? Now we're going to substitute any of the 2 points into y equals to mx plus c to find c. Let's do that. So we are going to have, we have y equals to mx plus c. We have found m to be 7 over 5x plus c. Now we choose, are we substituting this one or this one? I like that a because it has no negative, so I'm gonna substitute a. It's 8 equals to 7 over 5 times 4, x is 4, plus c. When we calculate that, we are going to get a c of, let's just do it fast. Okay, I jumped some steps here. Forgive me, please. It's gonna be 8 minus 7 over 5. Excuse me, I will not do it again. I won't jump steps like this again. My apologies. That's gonna be 12 over 5. All right, perfecto. Then writing our equation in full, I'm gonna have y equals to 7 over 5x plus c, which is 12 over 5.